Hello and welcome to a new lecture on using the capabilities of the ConceptBase system. The topic of today is using graphical types. My name is Manfred Joisfeld and I am one of the creators of the ConceptBase system. So let's start. We use a very simple modeling notation to demonstrate graphical types that are so-called organic graphs, also developed by Mintzberg and others, where you have organizational units that somehow link to other organizational unit by sending them some information or some material. So the concepts are like here, just you have a unit and it has just one attribute or link that is called pushes, and that goes to another unit. So you can link units to each other by pushes links. Very simple graphs. So let's define some instances. Copy them from another text editor. So here we have a unit O1 that pushes something to units O2, O3, and O4. Then O2, O3, O4 are units that are not pushing anything to some other unit, so dead ends in a way. Then we have unit O5 that pushes to 3 units, and some other units push to O5, so O9 for example. So we'll later call this a hub unit. Yeah, for example, O9 pushes to O5. So let's tell this and show this in the graph browser. Oops, sorry. Didn't tell the original definition. So that should be here. So let's try again. And now it works. So if we now start to display that in the graph editor, then it looks like this. You have just an ordinary node like O1, and that has some links to some others here, like this. So that's the standard graphical types that are applicable here to by default. You can always check out an object like O1 and look at the graph types. So this is a default type, default individual types. Individuals are node-like objects, so that's how by default node-like objects are displayed. Let's see what this is. This has yeah, default attribute type. That's also default types. ConceptBase has quite a number of these default type. Let's see the instances of the class of O1. So O1 is a unit, and that has as graphical type yeah, default individual, but also class GT. So in the graphical type is typically assigned by a rule to an object, and there could be several rules. So there could be several graphical types applicable, and then there will be a priority mechanism. For each graphical type can have a priority number, and if, for example, the priority of class GT is greater than default individual, then this will be preferred. And actually, this is the case. So let's show that and display that in the Telos editor. Then you see how this class GT looks like. It has this greenish like or bluish green-blue color. The text color is black. The line color of the border is black. The shape is a rectangle. The priority is 5, so relatively low. And this just tells the graph editor that it is a so-called node or individual object. So it will be displayed like a node-like shape. So now we would like to have some more elaborate graphical type for this, that we would like to have circles for the organization units, and these links should be displayed by a special type of link, a gray type of link. So we can forget about this and start to define our own graphical types. To do so, we first have to define a relatively complex interface object that will be given in the description. All the source code will be given in the description. And the whole purpose of this is to embed user-defined graphical palettes into the default type. So for example, you may remember that we have default individual graphical type, and the new palette that we define must make sure that we always have this graphical type. So the X palette is a given object that we tell to make our life a little bit easier to define our own graphical palettes. So that's about it. And the next is a very simple graphical palette for displaying the units and the pushes links with a special graphical types. So this is the plain graphical palette for organic graphs. It's defined to be a specialization of XPalette, and that will mean that it is embedded in the default graphical types that the ConceptBase graph browser expects. So this uses two graphical types definitions, unit GT and pushes link GT. We have to define them. So first the unit GT. Make it a little bit bigger. So that is a graphical type that has white background color. The text color is black, the line color is also black, and the initial size is 30 times 30 pixel. It will be displayed by a circle. The name will be displayed in italic. It is a node-like object. The priority now is 20, so much more than 5. And this is important. This is a rule that assigns this graphical type to all instances of unit. So then the system knows that this is a possible graphical type. So that is the unit graphical type. We also have to include the link. So that is the graphical type for the link. It has a text color 0. Well, but the text label will be set to an empty string, so there is no label to be displayed. The edge color is a gray. The edge width is 2 pixel, so that we can easily see that. Well, this is for visualizing the center of the edge, that if you want to move that. So it will be displayed by a little square dot on the edge. Since we have no label, we want to see where the edge can be moved. It will be not a node-like object, it will be a link-like object, so we have to specify here this CB link. and the priority is 8, which will be more than the default attribute type that we had before. And every instance of the pushes link of units will get this graph type. So pretty much like for the unit, we define it also for the links of our graphical notation. So let's tell that. And now, yes, let's start with O1. So O1 here, we load that into the graphical editor. And indeed, it is a circle, and it has white background. The label here is italics, and the edge, the line color is also black. So let's see whether we have some outgoing links, and these are indeed some outgoing links, and they are in this gray color and have no label. And if I click on this, you see there's a little dot here, if you look very carefully, that you can find the edge center where you can move the edge if you want. If you want to straighten the edge, you can use this function straighten edge. So that's a very simple set of graphical types here to be used. In the next step, we would like to display these nodes in a different color if depending on the number of inputs and outputs. So this has a lot of outputs and this has no output. So no pushes link here. So they should be distinguished by a color. So let's see how we can do that. And to do that, we define another graphical palette. That is this one here. It's a highlight palette. We'll give it the name Organic Graph Highlight. It's also using our interface palette XPalette. It uses these two graphical types that we already had before, and it has these additional types for so-called set types, one incoming link and more than 2 outgoing. Chain is 1 incoming, 1 outgoing. Hub is at least 2 incoming and 2 outgoing. And chain start is the first unit before a chain unit, and chain end is the first unit after a chain. That may be a bit complicated at the moment. So let's first define what we define by this, what we mean by this here. To do so, we define some queries. So the first query gives us the output units from a given start unit. So the 2 units are those units that are reachable by the pushes link from the given unit. So that is kind of the output, and the from unit are the input of this unit. So units that push something to the given unit given by the parameter. So that are auxiliary queries for defining our structure. Then now we can define what is for example, what is a set unit. So a set unit is a unit that has at least 2 outputs and 1 input. Exactly 1 input. So I already told that. And then we can define the others in one operation. So well, we already told this one, don't need that. A hub unit has at least 2 inputs and at least 2 outputs. Chain unit has exactly 1 input and 1 output, and chain start Well, that is not a chain unit, but the next unit is a chain unit, and chain end is not a chain unit, but the previous one is a chain unit. So let's tell this. The sources will be in a link that I provide for this video. So now that these queries define the structure. So if we go back here, and then we should be able to see that this, for example, is a set unit. Actually, it has incoming links here. Oh, 13 is an incoming link. It only has one incoming link and 3 outgoing, so it qualifies as a set unit. This one is actually a chain unit, so it has exactly one output and exactly one input. So let's see the input. Yeah, so that's 012. So this is also the last chain unit, such that the successor here is not a chain unit. So that was the definition of a chain end unit. So we'll see that here, chain end unit. Yeah, as I said, we would like to highlight these nodes in a way that we directly see what type of unit that is. Well, this is both a set unit and a chain end unit, so there will be some priorities. I think set unit will have a higher priority than this, so it will get the graphical type of set unit. So let's do that, and we have to go back to our definition of the highlight palette. So that is the additional graphical types that we have to specify. Set, chain, hub, and chain start and chain end graphical types. They are defined as to be a part of the container. This is already known, so it's also part of the plain palette. So you can reuse existing palettes, and the contains relation tells you which graphical types are currently active when you select a certain graphical palette. We have to define these new graphical types. It's quite a number. Let's go back to the top. So the set unit has a kind of a yellowish color. Otherwise it is the same. It has a relatively high priority, so that it's higher than, for example, the unit graphical type. Hub unit has 31 as priority. Note that we have here this rule. Every hub unit has this as graphical type. Note that this is a query, and being an instance of this query class determines that this unit has this graphical type, hub graphical type, which is this violet-like color. Chain units are here, so quite a number of graphical types, but they all look very similar. They only are different in the color here, and well, of course, they have to have this membership rule. And here you see the priority to determine which one is taking over. So let's tell that was successful. Now we should be able to change the graphical palette of our visualization. So we now have also highlight. We select that, and you will see they change the color according to the class of the or to the structure of this node. This is a set unit, so it gets this yellowish color. We can continue this. Let's see, this superclass here is unit. Let's display all the instances of unit. and remove that, and then we see all the graphical types. So maybe I missed some of them here. Anyway, change graphical palette. Let's go back to plane and then go back to highlight. Now it works. Good. So we had to change the graphical palette several times. So this 05 is an instance of hub unit. Oops. So that's why it gets this color, and it is some outgoing links. So that's these links here. Good. So that completes this little exercise on graphical palettes. I want to show that you can also go back to the default palette. Oh, that's not working at the moment. Good. So that finishes the presentation. Sorry for the little confusion at the end. The sources of the definitions are will be made available as links, and also a graph file where you can directly dig into the graph by starting CBGraph with this graph file. Thank you very much, and bye-bye.